Before we can study conductivity of solutions, we need a quick review of solubility. Solubility of ionic compounds involves breaking ionic bonds. And when we talk about dissolving right now, we're only talking about dissolving in water. So if we have an ionic compound, such as sodium chloride, then the ions are stuck together in a rigid crystalline structure. The ions are completely immobilized. But when you add water, or when you add the substance to water, then those ionic bonds break, and you end up with aqueous ions in solution. So when covalent compounds dissolve, covalent compounds don't break bonds when they dissolve, they break intermolecular forces. Right, so if we have a sugar molecule, sugar molecules don't actually look like that, but it's a quick representation of them. So these would stick together by hydrogen bonding. As we learned last week, not really a bond, it's an interaction, an intermolecular force, but we're calling it a bond anyway. So those will break, and you just end up with sugar molecules floating around in solution. The sugar molecules will detach from each other, but they will not form ions. That's the main difference. Ionic compounds will form ions in solution, and covalent compounds, while each individual molecule will separate from one another, they will not form ions. So electrolytes are substances that form ions in solution. Right, so strong electrolytes will ionize completely. Okay, so this sodium chloride that we looked at up here, that ionizes completely. If I put 100 units of sodium chloride in some water, I would have 100 sodium ions and 100 chloride ions. Every single one of them would separate from one another. Weak electrolytes only partially ionize in solution. Okay, so if sodium chloride was a weak electrolyte, which it's not, then if I put 100 units of it in water, I would end up with 99 units of sodium chloride and then just 1 unit of each ion. And we'll look at an example in just a moment. And non-electrolytes don't form ions at all. So these sugar molecules are non-electrolytes. Now this ionization is important because we're talking about the conductivity of a solution. Conductivity is the ability of an electrical current to flow through the solution. So in order for a solution to be conductive, it has to have ions in solution. Not only does it have to have ions, it has to have free ions that can move. And so in this lab, we'll explore some strong electrolytes, and these strong electrolytes include soluble ionic compounds, such as that sodium chloride that we looked at originally. Look at strong acids, and we'll say more about those later, and strong bases. We'll go into more detail on a future section of this lab. We'll deal with some weak electrolytes, such as weak acids or weak bases. And we'll see some non-electrolytes, which can be covalent compounds or insoluble compounds.